Welcome to the Hitchhiker's Guide to Calculus. My name's Kevin, and I'll be your guide to Chapter 1.3, Evaluating Limits from a Graph. First, let's take a look at this crazy graph I've got drawn here, f of x. It's got a bunch of jumps, random points. Who knows what's going on there? Probably different than any function you've ever seen. And off to the right, we have some problems that we're going to ask about it. We'll start with what's happening at our function at -3, f of -3. That's literally the point that's happening when x is -3. What's the y value? You look at the graph, we see at -3, we've got a y value. It looks like it's a y value of 2. That we've done in algebra. Now the question is, what about these limits? What's the limit as x approaches -3 from the left? I like to imagine that I'm a person standing on my function a little bit to the left of -3, and I want to walk towards -3. Now, it doesn't matter anything at all that's happening over here to the right. The only thing that matters is where I'm standing and what y value am I approaching as I get closer to the x value of -3. Now, I've scribbled over that, but it looks like the y value that I'm approaching is 1, 2, 3, 4 from the left-hand side. Okay, we can do the same thing from the right. All right, we erase our little guy. We jump over to the right side of my function, a little bit to the right of -3, and I imagine myself walking to the left. Now, this is probably the one that's hardest for students to grasp because we usually read our functions left to right. But here, when I'm coming from the right, I want to travel right to left. And I want to see what's the y value that my function's approaching. And it looks like from the right of -3, our function's approaching a y value of -1. You can see that these two limits don't agree with each other. So the final question here, the limit as x approaches -3, we say the answer does not exist because the two sides don't agree with each other. The evidence doesn't support a conclusive answer. Right? Same story, but now we can look over to the right at what's happening when x is 2. Again, f of 2, I just want to know what the point is. Okay, there's a point at x is 2, y is 1. So f of 2 should be 1. If we approach 2 from the left-hand side, now we're going to put our person a little bit to the left. We travel to the right, and it looks like we're going towards that point. So here we would say the limit as x approaches 2 from the left is also 1. Right? What if I wanted to approach 2 from the right-hand side? Draw my guy a little bit to the right of 2. I travel right to left, and I just say, okay, what's the y value that my guy is going to approach? 1, 2, 3, 4, 5, it looks like. So from the right-hand side of 2, my function is approaching a y value of 5. Now, it's important to note that a limit doesn't care if there's a point that I'm going towards or a hole that I'm going towards. It just matters what y value am I going towards, point or no point. Just like last time, these two answers don't agree with each other. So my conclusion has to be that the limit as x approaches 2 doesn't exist. Let's erase our guys and do one last round, and let's look at what's happening at x equals 5, which is not very exciting in terms of this graph, and lots of people make that mistake and treat it as something a little bit harder, but it's actually the easiest case. At 5, we can see that the y value is 2. And if I draw my guy and I approach 5 from the left, where am I walking towards? I'm walking right towards that point. Again, a y value of 2. If I approach from the right-hand side of 5, there's my guy on the right. I'm walking right to left, and I'm approaching that point as well. So both of these limits are approaching 2, and if both of them agree with each other, then we can make the conclusion that, yes, of course, the overall limit as x approaches 5 of our function must be 2. To see more videos like this, click subscribe. Or to continue your journey through calculus, click the next video on your left.